Okay, second type of reaction in our unit, the decomposition reactions. And I think these will be familiar from grade 10 also. We've just reviewed synthesis, and now we're focusing in on reactions that have one reactant. So you'll see whatever our reactant is here, there's no plus signs. That means that this substance is one substance. So we have one reactant forming at least two products, might be three. I'll go through some specific patterns with you. Okay, so in terms of the common patterns for decomposition that you'll be seeing, first one, most straightforward, would be if you have a binary ionic compound. It's definitely decomposing into its elements, and so we just need to write those elements in their elemental form. So calcium oxide, which we know is a solid as an ionic compound, decomposes, and you need to heat this. So just to let you know, the triangle over the arrow means heat. So calcium oxide is going to decompose into the elements that it's made from. So it's made of calcium and it's made of oxygen. So now you have to ask yourself if these elements are diatomic, and if they are, to adjust the formula and then include the state. Calcium is not one of the diatomic elements. It is a metal, so it's a solid at room temperature, and then the oxygen is diatomic and it's a gas. So that's all we do, write the elements and now balance the equation. So I'm noticing one calcium over here and one over here, that looks good. One oxygen and two oxygen, so I'll come back over here and adjust the oxygen, so there's two on both sides, which has now affected the calcium, so I better come back and balance the calcium. Okay. Number 2 is very much like number 1, except that it's a molecular compound. So if we have a binary molecular compound, then it will also decompose into its elements. So using the exact same strategy we did for number 1, write the elements that water is made of as the products, decide if they're diatomic or not, include their subscripts, and balance the equation. Okay, so hydrogen is diatomic, H2 gas, oxygen is also diatomic, O2 gas. Set up our coefficients, our lines for balancing, go ahead and balance, and we finish with 2, 2, 1. Again, that blank is a 1. Okay, third pattern, and I would just maybe draw your attention to this one in particular because I find that people seem to not pay attention to this, and when it shows up on the test, you've either memorized it or you haven't. So it's a tricky one. Polyatomic compounds decompose into one element and a compound, and sometimes that's tricky to see. I realize that H2O2 looks binary, but let's remember that this is hydrogen peroxide, and so in fact there's a polyatomic ion of peroxide here. You would have done this reaction in grade 10 in your types of reactions lab. And I'll refresh your memory by saying that a black powder, which is a catalyst, manganese dioxide, is added to hydrogen peroxide to increase the rate of this reaction. And we use a glowing splint to test for the gas that is produced. So do you remember your gas tests? Which gas supports combustion? Which gas, when you put a glowing splint into it, will reignite into a flame? Well, hopefully you're thinking of oxygen gas. And now what's left? Well, we need a compound, which the only two elements we have to work with are hydrogen and oxygen. So I'll give you a hint here. The compound is a colorless, odorless liquid that is very abundant in our world. And if you're coming up with water, then you're correct. Okay, last step to balance. We look at our H's, they're both at 2, and we look at the oxygens. It looks like we need a 2 here to balance the oxygens, which now brings our hydrogen up to 4 in total, so I'd better put a 2, so that 2 times 2 is 4. Okay, second pattern in the polyatomic compound decomposition, a metal chlorate. So I'm giving you the instruction that a metal chlorate decomposes into a metal chloride, there's the compound, and oxygen. So use your cross-down method for the metal chloride and write the formula of oxygen, include your states, and go ahead and balance the equation. Then check in with the video. Okay, so you'll see that for the metal chloride, the metal in this reactant, potassium chlorate, is potassium. And so I write the K with its charge of +1, Cl with its charge of -1, cross my charges down, and have KCl. That's an ionic compound. Water is not present anywhere here, and so I can go with the state of solid. Oxygen, O2, is diatomic, and it's a gas at room temperature. Then I go ahead and balance. Okay, last pattern here for the polyatomic compound decomposition. A metal carbonate. So a metal carbonate decomposes into a metal oxide and carbon dioxide. So a different gas is produced here. Again, we need to heat it. And so here I'm giving you the example of tin 2 carbonate. So I've chosen a multivalent metal here just to show you how that works. Whatever the charge is on the tin in this compound will be the same charge on the tin in the metal oxide. So if it's tin 2 on this side, tin 2 carbonate, then this will be tin 2 oxide. So go ahead and predict your products, put your states, balance the equation. Then check back with the video. Okay, so you'll notice for tin 2 oxide that I wrote the charges, tin +2, O -2, cross the charges down, and then those 2-to-2 ratio reduces to 1-to-1, and so I have SNO. Formula for carbon dioxide is here, it's a gas, and now I can balance the equation. Checking things out, I see 1 tin here and 1 over here, 1 carbon here and 1 over here, and 3 oxygens on the left side, and as I check the right side I have 1 here plus these 2 is 3, and therefore I don't need to place any coefficients. Okay, so that's it for the decomposition patterns.